interpret, friends. Let's interpret what this means. What does this mean? No, confusion. That's a good answer. That's a good answer. It probably does confuse right now. 99% confidence interval for the percentage of heads. So, let me see if I can get a feeling on how we feel about the individual components of this. I think we're okay with this 47%. We're getting that. 47%, that was our sample. 47%, boom. How we feel about the 7%. And when I say that, I don't mean the calculation of that 7%. We'll deal with that momentarily. The machine will take care of the whole calculation for us at once. How do we feel about the 7% and why we need it? Do we understand why we need the 7% on there? Why do we need it again? Remind me. Because if I had 340 other coin spins, what's going to happen? Okay, it could be different. So let me actually show you guys something. Not only do I have that, I've got about 4,000 of them. I've kept track of this for the past 8 years. Yeah, I know. It's me. So here is what it looks like. There they are. This is the results of this experiment with their corresponding confidence intervals over time. Yeah, hopefully you can read that a little bit. So, now these are at 95% confidence. I'm sorry, Carly, I ignored your 99 for this one. One with 99, one with 95. Why did I go with 95? Is it my bastard? No. 95 is, well maybe I should answer that for you. 95% confidence is fairly industry standard. We'll talk more about that as we go through this course. Generally, the 2 standard deviation rule, the 95% confidence is almost universally used. I'm not saying that's a good thing. I'm saying that is a thing. It's kind of just the way it is. So, please take a look at this. Here are you guys, right here, spring 14, and there's your confidence interval from 40% up to about 54%. Okay? Here's the guys that came before you. Winter 2014. They did 310 spins and got 142 heads. There's their little interval right there. But before them was fall 2013. Out of 260 spins, they got exactly 130 heads, which is exactly 50%. Notice where their confidence interval is. This line is 50%. You can't see that, I'm sorry. You can't see it. This is 0%, 25%, 50%, 75%, and 100%. So theirs landed exactly centered on 50%. Now what do you notice about some of these intervals? For example, with the spring 13, exactly 1 year ago, spring 13, using the same pennies you guys did.
Larger.
They did 430 spins, and they got 180, where are these .0? I don't know. 189 heads. Their interval looks like this. So it looks to be about, I don't know, maybe 39% to about 49% or something like that, ish. Do you notice how some of the intervals are wider and some of the intervals are narrower? Why would that be? Why would that be?
The sample size.
Boom! When your sample size is larger, what's going to happen to your interval? It's going to get narrower. You guys figured this out almost immediately in 243. The larger your sample, the skinnier your interval. And think about why in that calculation. In that calculation, we divided by 340. If you divide by a larger number, the overriding number is going to get smaller. So some of these that are more narrow had a larger sample than those that are wider. Now they're all pretty close. I mean, let's say the largest is around 540. Fall 2007 had a 540. Pretty narrow indeed. What do you also notice about some of the intervals versus the other ones? What do some of them do and what do some of them not do with respect to this beautiful number that started this whole problem? Some of the intervals do not contain the number 50%. What does that tell us? What does that tell us when we encounter an interval like these, that does not include 50%? What does that tell us about the coin spins? Better yet, let me give you a better example. This is the interval up here. This is the confidence interval of every single data point that I've ever collected from 2006 to you guys. You're in there as well. The p-hat value historically is 44%, which is not that far from what you guys got at 47%. But look at that interval. Look at that interval. It's essentially maybe 1% wide, yes? Maybe 1% wide. What does that tell us about spinning a coin versus flipping a coin? What does that tell us about spinning a coin versus flipping a coin?
On average, over time, it will be less than 50%.
You're less likely to get heads when you spin a coin than when you flip it. That's what that little orange confidence interval up top tells us. Now, how can I say that with confidence?
On average, over time.
Oh, good, good. But how does that interval, that orange one up there, how does that orange interval allow me? Let me ask a different question. Can our data, let me scroll down. Can our data right here allow me to say that? Just our data? Forget the other ones, just look at ours. Does our interval imply that there's a difference between spinning and flipping? And my vote is nope. Why? How is it nope for us? Good. We're like, wait a minute. I was going to say yes. How is it that it's no for our interval? It's no for our interval, but it's yes for this one up here. Cassidy, go! Go, my friend, be brave! Be brave, go! No, come on! You got this. What number? Go ahead. We contain 50, you got it, sister. We contain 50% in our interval. Can I claim, crap, I moved it again. I'm gonna go over here. I like my drawing better anyway. It's one thing at a time. When we look at our interval right